So what does a simple coiled spring have in common with the electrical socket in your wall? Well, it might sound a little strange, but they're both part of the exact same incredible journey, the journey of energy. It's a story that starts with a simple stretch and ends with enough power to light up our entire world. Today, we're going to follow that path from the very beginning to the very end.
All right, so here's our game plan. We're going to start small, really small, looking at the hidden energy in everyday objects. Then we're going to zoom out, step by step, until we're looking at the massive electrical grid that powers the whole country. And of course, we'll wrap up with how to handle all that power safely. So first things first, let's talk about the power of potential. This is all about the unseen force that's kind of lurking in the most ordinary things around us. It's an energy that's just waiting to be released. So where exactly is all this energy hiding? It's not always a big flash of light or a roaring engine. Most of the time, it's completely silent, just held in tension, ready to, well, spring into action. This hidden power has a name, of course. It's called stored energy, or you might have heard it called potential energy. Just think of it like energy being held on standby inside an object, waiting for that perfect moment to burst out as movement. And once you start looking for it, you see this stuff everywhere. I mean, every time you stretch a rubber band, you're literally loading it with potential energy. It's the same thing happening with the spring in a jack-in-the-box, a set mousetrap, or even the coils inside your mattress. Okay, so we've got all this stored up energy. Great, but how do we actually make it do something useful? Well, that brings us to our next big step, going from springs to wheels and turning all that potential into useful motion. Now, to put energy to work, we need a system. That word might sound a little complicated, but it's not. A system is just a bunch of parts that work together to get a job done. A bicycle is a perfect example, right? The pedals, the chain, the wheels, they all team up as a system to turn your leg power into forward motion. And speaking of systems, let's look at maybe the most important one ever invented, the wheel. It's incredible to think we went from these heavy, solid wood wheels 5,000 years ago to lighter, spoked wheels. But the real game changer? That came in 1888 with the air-filled tire, which made travel so much smoother and faster. It just shows how we're always tweaking systems to make them better. Right at the heart of that system is the axle, and they basically come in two main flavors. You've got your rotating axle, where the axle and the wheels turn together, kind of like on roller skates. It's simple, but a little wobbly. Then there's the fixed axle, where the wheels spin around a bar that stays put, like on a bike. That design gives you way more stability and control. Okay, so we've gone from stored potential to actual physical motion. Now, let's shrink that whole concept way down and put that power right into our pockets. It's time to make the jump from mechanical energy to chemical energy. All right, here's something that trips a lot of people up, so let's clear it up. A single cell is the basic unit that stores chemical energy and turns it into electricity. What we usually call a battery, like a 9-volt or a car battery, is actually a package of one or more of these cells all hooked up and working together. And we use two main types of these every single day. You've got your non-rechargeable cells. They're cheaper to buy, but they're one and done. Then you have the rechargeable kind, like in your phone. They cost a bit more at first, but since you can reuse them hundreds of times, they end up being cheaper and way better for the environment in the long run. But look, all this portable power comes with a huge responsibility. The chemicals inside these things can be really nasty if they leak out into the soil or water. Some types, like the lithium-ion cells we all carry around, can even catch fire. This is why it's absolutely critical that we dispose of them or recycle them the right way. So, now we've got a portable power source. But how do we actually control that energy and tell it where to go? That brings us to the path of electricity. The answer is a circuit. And for electricity to do anything at all, it needs a closed path, a complete, unbroken loop to travel on. It has to flow from the source, through whatever device it's powering, and all the way back again. If that path is broken anywhere, it all just stops. When you boil it down, a simple circuit is really just made of 4 essential parts. You need an energy source, like a cell. You need a conductor, usually a wire, to be the pathway. You need a device, like this light bulb, to actually do the work. And finally, you need a controller, like a switch, to open and close that path whenever you want. All right, we've nailed the basics. Now I want you to get ready for a massive jump and scale. We are going from a single tiny light bulb to powering an entire country. Welcome to the national circuit. Seriously, just let this idea sink in for a second. Picture that simple four-part circuit we just looked at. Now imagine stretching it and stretching it until it's as big as a whole country, because that is literally what the national power grid is. And get this, it follows the exact same basic rules. The power plant, that's your energy source. The huge transmission lines, those are the conductors. Substations act like giant switches and controllers. And your home or your school, that's the device at the end of the line. It's the same system, just on a totally epic scale. So where does all the juice for this giant circuit come from? Well, we use a mix of sources, and every single one has its own trade-offs. Coal is reliable, but it pollutes. Solar and wind are clean, but you're at the mercy of the weather. And nuclear is incredibly powerful, but you're left with hazardous waste. As you can see, balancing our energy needs is a really complex puzzle with no single perfect answer.
Okay, we've gone all the way from a coiled spring to the national grid. Now let's bring it all the way back home, to you and the socket on your wall, and talk about how to handle this incredible force safely.
To stay safe, you just have to remember one thing. Electricity is lazy. It's always looking for the quickest and easiest path to the ground. It loves to travel through things like metal and water, and dangerously for us, our bodies. That's why we use insulators, like rubber and plastic, to block its path and keep us safe.
Okay, this is vital. If you ever see an electrical emergency, you have to remember these 3 steps. First, if you can do it safely, kill the power. Second, call for professional help immediately. And third, and this is the most important one, never ever touch the person who is being shocked. You could become part of the circuit yourself.
So, from the hidden potential in a tiny spring to the vast network that powers our entire lives, the journey of energy is really all about harnessing and controlling its flow. And that leaves us with one final really important question to think about. As our world needs more and more energy, how can all of us work together to use it smarter and safer in the future?